Hello, let's do this. So we have our skier. So we're going to draw a free body. I'm just going to overlay it on top of him. So we have 60 kilograms as our mass. So that's our gravity force. He's on the surface, but not like sinking into it, which means we have a normal force. Normal force. There is friction. Since we're going down, friction must be going up. So that's the force of friction. And it says we are at an angle of 35 degrees. So let's figure out this acceleration. So a couple things. First of all, I'm going to break this gravity into its components. Part of it is going down the hill, and part of it is going into the hill. And this down the hill and into the hill, they make a right angle. The X and Y are always at a right angle to each other, which is really handy. And so if we complete this triangle, this is also a right angle. So this is 35 degrees and that's 90. This is 90 minus 35. That's some number. 55? That's 55 degrees. So this is 55. 55. And that's 90. That means this is also 35 degrees. So he's going down the hill, which means down the hill must be winning. So going down the hill minus going up the hill, that's going to equal our MA. We need to figure out which part of this gravity is taking us down the hill. And to me, it was taking us down. That's the orange part of the triangle. That's this part. That's what's going down the hill. And that is opposite this 35 degree angle. So when I think angles, I'm thinking so, ka, twa. Which means, you're probably like, what does that mean? So the sine of any angle is opposite over hypotenuse. So the sine of 35 degrees in particular equals opposite. So what's opposite that angle? Well, that's the force of gravity in the x direction. That lime green one, we'll call that one the y direction. And then the hypotenuse of this triangle, that's like blue, green, orange, this triangle, the hypotenuse is Fg, our gravity force. Your teacher might call it mg, that's totally fine. So if we do Fg times the sine of 35, we get Fgx, the part that we care about. So if we're doing the sum of our forces, the sum of the forces in the x direction are going to equal ma. In the x direction, in the direction of motion, we have Fg sine 35. Opposing that motion is gravity. Gravity's going up the hill. It's fighting us. It's saying, no, don't go down, slow down. So that's why we subtract it. Equals ma. That's a true statement. We might end up using it, we might not. Another direction, we know that the force in the y direction also equals ma. However, in the y direction, we know that the normal force and whatever part of gravity is holding us into the hill, those are balanced. We're not sinking into the snow, we're not floating above the hill, neither of them are winning. So our acceleration in the y direction is 0. So the sum of the forces in the y direction are actually 0, which means going up, the normal force has to equal going down, which is Fg cosine theta, that green part, okay? And this is a pattern you'll see over and over again. So if they give you a hill and an angle of incline, the part of gravity going down the hill is going to be sine, and going into the hill is going cosine. The way I remember that is at the bottom of the hill, there's a stop sine. So going down the hill, you use sine. If you want to know why, you can look at this triangle and watch like that part of the video a couple times. But yeah, if they give you an angle of incline, the part of gravity that's going down the hill, sine. Fun fact. Okay, and they also told us the coefficient of friction is 0.08. So the force of friction equals mu times the normal force. We don't have the normal force, but hey, we have this equation which we can use to calculate it. Fg is one of the forces where we can calculate, so that's mg times the cosine of theta. The mass of this skier is 60. It's already in kilograms, which is really nice. I'm going to use 9.8 for gravity. Some teachers use 10. You do whatever your teacher says. And the angle, I ran out of room, 35. Oh, I hate that. I'm going to write it over here so there's like room. Okay, so the normal force is mass, which is 60, gravity, which is 9.8, times the cosine of 35. If we multiply that all out, make sure your calculators is in degrees, not radians. I was in degrees, sweet. This ends up being 481 newtons. So over here, I can do my force of friction equals mu times normal. Mu is 0.08. And normal, which I just calculated over there, is apparently 481 newtons. So times 0.0. Oh, it's actually 42. So I'm not actually rounding. I'm just holding it in my calculator. So the friction force ends up being 38.5 newtons. So now we can come up here, because the ultimate goal is to calculate this acceleration. So now we're going to fill out this equation. So we're going to do mg sine 35 minus the force of friction, which we just calculated. We got a number for it, equals ma. Let's do this. So the mass is 60. Gravity is 9.8. Sine of 35 minus 38.5 equals the mass again, 60, times a. One equation, one unknown. We can do this. All right, so 60 times, well, I'm going to store that as x first. Then I'm going to do 60 times 9.8 times the sine of 35 minus that thing we calculated. Divided by 60, your acceleration should be 4.98 meters per second squared. Now that is the way to do it, where you do it in like 3 discrete steps. If you're a one big equation kind of person, that also works. I'm going to show this briefly just in case you're like, why did she do it that way? You could have done it this way. You totally could have. You could say down the hill is FG sine theta. Up the hill is friction equals ma. And you could have said, well, friction is mu normal. And the normal is mg cosine theta. So you could say FG sine theta minus mu mg cosine theta equals ma. And then FG you can say is mg sine theta minus mu mg cosine theta equals ma. You can cancel out your masses if you're feeling fancy. You can factor out your g's if you're feeling fancy. Depends how fancy you're feeling. If you're looking at this and you're just like, ew, no, what is she doing? Go back. You don't have to do it this way. Your teacher might solve it this way on the board. But all they're doing is they're doing these 3 steps like at the same time. So find that friction equals mu times normal. But hey, I don't have the normal. So use the fact that normal equals FG cosine theta. This normal here is balanced with FG cosine theta going this way. Those are going to be equal. Otherwise, it implies we're like sinking in the snow or floating above it. So that's what's going on there.